This is Algebra 2, Lesson 4-12. Today's date is January 17th. It is a digital day because of the snow. So if you have a printer, please print out these notes. For example, if you're at school, please print them out on your own. Or if you're at home, please print them out on your own if you have a printer. Regardless of what happens, these notes will be due on Monday. So I'm assuming by Friday we'll be able to print these out. And regardless of what happens also, the homework is going to be due tomorrow on Friday. So it's on Khan Academy. Everyone has the ability to watch the video and do the homework unless you have no internet, in which case you need to text me. All right, and you won't be able to know that unless I text you first, but I'll text you guys in a sec. So vocabulary, let's start this off. When I'm talking about the zeros of polynomials in terms of the graphical representation, we have these four words that describe almost the same thing. So let's talk about the word root. If I solve for an equation and I get something like x is equal to, let's just choose 7 to be our example. Maybe that looks like a greater than sign. Let's choose 4. X is equal to 4. That could be a root of the polynomial. So if I'm talking about the zeros, I'm only talking about the number. I don't have x equal to 4. So 4 could be the zero of that polynomial. And very similar to the idea of root and zero, which we've already been using, is this X-Intercept. So in terms of the graphical representation, an X-Intercept is something of the form, well, we know that 4 is the X-Intercept comma 0. So it's an actual point on a graph. These are all the same thing. Root, 0, X-Intercept, they're just in different forms. And then linear factor is a form when we're factoring the polynomial. So if I factor the polynomial and one of the factors is x minus 4, that allows me to set this linear factor to 0 to get the root as x equals 4, which lets me know that I have a 0 of 4, which also tells me that I have an X-Intercept at 4, 0. They're all interrelated. This would be a good idea to do a diagram that I can't remember the name of. Okay, so let's do an example. Find the X-intercepts of this polynomial. So it's the same thing that we've been doing before, where you want to factor everything that you can. I can see that I can factor this left-hand part by using Ninja Star. I can factor this right-hand part by doing difference of squares with a conjugate pair. So pause the video now, try it on your own, see if you remember how to do this. All right, you've unpaused the video. Let's go ahead and walk through this. So if I'm doing Ninja Star for the left, that means I have an x and an x. I multiply the top. 1 times negative 42 is negative 42. I do the middle, negative 1. What two things multiply to negative 42 and add to negative 1? That's going to be negative 7 and 6, which means this factors as x, a little bit of lag there, x minus 7 times the quantity of x plus 6. So that was this term right there. I haven't dealt with the second term. The second term is a difference of squares because I have an x squared term, which is a square, and I have a 9, which is also a square. So the way that we do a difference of squares is it's kind of like square rooting each of these terms. So a square root of x squared is just x, and square root of 9 is 3. And then I need a conjugate pair, so I need two pairs of x something 3, and then the pairs are going to be opposites, where you have a plus sign for one and x minus 3 for the other. So now this polynomial is completely factored. In order to find the roots, in order to find the X-intercepts, find the root, I set this whole polynomial equal to 0. This is the equivalent of saying y is set equal to 0, which is the same thing as finding the X-intercepts if you remember back from Algebra 1. Algebra 1, the definition of X-intercept is where y is equal to 0. So by setting this thing equal to 0, I'm really saying by the zero product property that each of these linear factors needs to be set equal to 0. So I can actually show you how to do that, or we can just do the shortcut method. The shortcut method, if I set this thing equal to 0, that means I need to add 7 to both sides, which means I get a root of x equal to 7. From this linear factor, I get a root of x is equal to negative 6. From this linear factor, I get a root of x equals to negative 3. And from this linear factor, I get a root of x is equal to 3. So the zeros are 7, negative 6, negative 3, and 3, which means my x-intercepts are for each of these x coordinates on that x-axis. So the x-intercepts are 7, 0, negative 6, 0, negative 3, 0, and 3, 0. And that's the final answer that we're looking for. And this problem isn't going to be on Khan Academy. This problem is in an attempt to show you how to do even harder problems. It's kind of like the baby step before we do the really hard problems. All right, so far that was half review, half new stuff. You know that X-intercepts are now related to the roots and linear factors. Let's go ahead and do a mini exploration. If you have your own computer and internet, try this on your own. Try to graph this function on Desmos. And then I'm going to ask you what you notice and wonder. If you're too lazy to do that, you can just stick around in the video right now because I'm going to show you what that graph looks like. So this is the graph of 6 times all of that polynomial. What do you notice and what do you wonder about this graph? I really want you to spend some time on this. I would say at least 3 minutes, if not 5 minutes. So please pause the video now. What do you notice and wonder about this graph, specifically about these orange points, which happen to be the x-intercepts for this polynomial? Alright, so we're back after pausing the video for a while. You should have a bunch of stuff in your notice and wonder column. Unfortunately, I can't hear back from you, but one thing that I noticed was that some of these x-intercepts, the line goes through, while other times it turns around. So sometimes the graph goes through, other times it turns around. And when I'm talking about this, I'm talking about the x-intercepts. And what do I wonder? One thing I wonder from this graph is, does this work if I had something like an x plus? I only see x minuses here. So one thing I wonder, is this the same for x plus something linear factors? Maybe it's different or something. And oh, look at this. I just saw something else that's cool. So x minus 1 refers to the x-intercept of 1. Look at what power it was. It was to the power of 3. X minus 2, this term right here was to the power of 2, and it turned around. So it went through for the power of 3, it turned around for the power of 2. Let's see, at 3, it was an odd power, and it went through the graph. At x equals 4, for that x-intercept, it's to the power of 4, and it turned around. Do you guys see another pattern? And maybe you already saw this pattern before you started watching the video after the pause. I notice here that when I have an odd power, that it goes through the graph, and when I have an even power, it turns around. And that's a really important rule. We'll talk about that down here, but in order to talk about this rule, we need to formally define what's happening. And what's really happening is called multiplicity. So this is the same polynomial as up above. I'm going to talk about these terms with the correct vocabulary. So this linear factor here, x minus 1 to the power of 3, it has a 0. The 0 is 1. I find 1 because I set this thing equal to 0. I cube root both sides, and I have x minus 1. And if I cube root 0, it's still 0. And then I have x minus 1 is equal to 0. And then I solve, and I get x equals 1, which is a root. And then 1 is therefore a 0. So the 0, 1, which comes from this linear factor right here, has a multiplicity of 3 because it's raised to the power of 3. Another name for this is a triple 0 because the 0 has 3 of them. There's a triple 0. So let's look at this one. This 0 right here, it's a 0 of 2. It has multiplicity of what? And you should be saying, oh, it has a multiplicity of 2 because it's to the power of 2, and you're correct. It has a multiplicity of 2, and what is that known as? What would be your guess? You would be correct. It is a double 0. Double 0. So that's just how to talk about these terms. So now let's talk about that rule from this graph from Desmos that we were looking at. Whenever I had an odd multiplicity or an odd power here, it went through. So we want to say that. Even multiplicity goes through, or I should say it crosses. It crosses the x-axis. Oh wait, that's for even. I should be writing that in odd, sorry. So odd crosses the x-axis. But when I have an even number, so let's look at our even numbers, x minus 2, when it's even, it turns around. It turns back. Another way to say that is that it just touches the x-axis and then comes back. So I'm going to use the word touches, like you go up to a fence, you touch it, and then you run away, or you ring a doorbell and then you run away. So I'm going to say it touches. So even multiplicity just touches the x-axis and then runs away. It touches and then runs away. Okay, so let's go to example 2. This is where we apply all of the knowledge that we've gotten from the first side of the sheet of our notes, and then we can actually graph these guys. So which of the following graphs could be the graph of the following polynomial? We have x squared plus x minus 2, that times x minus 1. Well, it's the same process as before. We need to factor this guy, set it equal to 0. We need to find the x-intercepts. That's the first step. So I need to factor this thing. It looks like I have 3 terms here, which means I'm using Ninja Star. Go ahead and pause the video now. Try to do this on your own. Find the X-Intercepts. All right, you've unpaused the video. So by doing Ninja Star, we should get an X, a 1, and sorry, it should be a -2 on top and a 1. What two things multiply to -2 and add a 1? 2 and -1. So this factors as x plus 2, x minus 1, x minus 1. That is fully factored now. Now I'm going to set it equal to 0 to find the roots, and I find that I'm going to get x is equal to -2, x is equal to 1, x is equal to 1. Oh, I have a repeat of x equals 1, which is the same thing as saying I could have gotten rid of this term and taken this to the power of 2, meaning we have a multiplicity of 2. This 1 is a double 0. So we'll just point to this, say double, a double 0, and this is a single 0. Single 0, or it has a multiplicity of 1, has a multiplicity of 2. All right, so first of all, let's check all the graphs, make sure that they touch or cross the x-axis. They have 3 x-intercepts, or sorry, they have 2 x-intercepts because we have 2 x-intercepts. So that one has 2, that one has 2, that one has 2, that one has 3. It's definitely not D because that has 3 x-intercepts. Okay, let's talk about A, B, and C. We have to figure out which one of these touch and which of them cross. Remember the rule. So if I have a single or an odd multiplicity goes through, which means the position x equals -2 should go through the graph. This one touches and goes backwards. This one touches and goes backwards the other way, so the correct answer is C. This is the only thing that has x equals -2, which is right there for the x-intercept, that goes through the x-axis. And then we can check this one too. So x equals 1, it should touch and then go back. It only touches the x-axis. At x equals 1, it touches the x-axis and then goes back. So that's exactly what we're looking for. It is indeed C. All right, example 3. I want you to try all of example 3 all on your own to see if you can figure out which graph it is, and then unpause the video. All right, you've unpaused the video. This is our final problem. Here we go. I'm going to factor this x squared minus 4 as the difference of squares, which turns into x plus 2 times the quantity of x minus 2. And then this has 3 terms, so that means it's going to be a Ninja Star problem. After you do your Ninja Star, it's going to be x plus 3 times the quantity of x minus 2. I can stop right here and do a little shortcut. This x minus 2 has been repeated twice, which means I'm going to scribble this out and say this is really to the power of 2. I know it's going to have a multiplicity of 2. So what are my x-intercepts going to be? Well, my roots are x equals -2, x equals +2, and x is equal to -3. Right away, I know I have 3 different x-intercepts. So I'm looking for a graph that has 3 x-intercepts. Uh-oh, A has 4, it's not A. B, C, and D all have 3 intercepts, so it's between B, C, and D. Now let's check the multiplicity of each of them. So at x equals -2, or sorry, let's do -3, that's the far left. On the far left, that has a multiplicity of 1, which means it's odd, which means it goes through the x-axis. Which of these goes through the x-axis? That one is good, so we can do a little check mark. That one goes through, this one goes through, and that one goes through. Okay, it didn't really help us very much. Let's go to the next one, x minus 2. This one is also odd, which means it should go through the x-axis. This one turns around. It only touches and then goes backward. This one goes through, that one's good, and this one goes through. Okay, we've eliminated B. B touched and then went backwards. And then finally, we're going to check x equals 2. X equals 2 has a multiplicity of 2, which is even, therefore it touches but does not cross. So this one crosses, not good. This one touches and then goes backward. That one is good. So our correct answer is D. All right, so please write your summary. Remember that the notes are going to be due on Monday and the homework on Khan Academy is due tomorrow on Friday. I'll see you guys tomorrow.